Today's question: a charge small q is placed at the center of the line joining two equal charges capital Q. The system of three charges will be in equilibrium if small q is equal to. So here two charges are given denoted by capital Q. Let us assume they are separated by a distance d. A charge small q is placed at the center. So this is a small charge kept at the center. So distance is d by 2, d by 2. The system of the three charges will be in equilibrium. Now this charge is placed. We have to find out what should be its value so that the entire system is in equilibrium. Now for the system to be in equilibrium, the resultant force on any of these two charges given, that is capital Q, should be 0. So let us name this as point A, center O, and point B. So the resultant force of any of these two charges should be 0. For the entire system to be in equilibrium, we have to find out its value. So the resultant force on A due to O plus resultant force on A due to B should be equal to 0. So we are trying to find out the resultant force on plus Q placed at point A. You can also find out the resultant force on B because it is the same charge. Now we apply the Coulomb's law. So this value is K Q Q d by 2 whole square. And now the Coulomb's law between point A and B. So K Q Q, that is Q square upon D square, that is equal to 0. Therefore 4 K Q Q upon D square, this d by 2 whole square, so it becomes 4 plus K Q square D square is equal to 0. We have to find out the value of small q. So this implies 4 K Q Q upon D square is equal to minus K Q square upon D square. So K D square cancelled, 1 Q is also cancelled. So the value of small q comes out to be minus q by 4. So if the charge which is at the center is negative and its value is q by 4, then the system will remain in equilibrium. So the correct option is option A, that is minus q by 4.